Hello everybody, this is Skill 20. We are going to be solving polynomial equations, and today we're going to focus on that idea through factoring. So you may remember that a couple of days ago we had you doing some factoring practice, and the reason we asked you to do that was so that you could still remember your factoring techniques, so that when you do this assignment you'll be up to speed. Alright, so let's start by taking a look at these two types of equations. Well, how would we solve these kind of equations? Well, if I look at the first one, you'll notice that I have x times x squared minus 9. Well, hopefully you remember that x squared minus 9 is a difference of squares, and that'll factor as x plus 3 times x minus 3. We never want to forget the original factor. And so now we have this in fully factored form, which allows us then to solve by using our zero product property. In other words, what that means is we set each factor equal to 0. The first one's already solved, so I don't have to do anything. Second one, I'm going to subtract 3 from both sides, and x equals negative 3 is a 0. And I'm going to add 3 to both sides on this equation, and x equals 3 is a 0. So our solutions are 0, negative 3, and 3. Okay, and remember we call those zeros. If I look at this next one, I see x plus 5 is already a factor, but 4x squared minus 16. Well, 4 is a perfect square, 16 is a perfect square. Both of those also have a GCF of 4. Oops. So actually, I'm going to write this, I'm going to do an intermediate step here. So I'm going to write this as 4, and then I'll have x squared minus 4, which then I can break down as x plus 2, x minus 2. I have this x plus 5 that I'm going to bring here with it, and that GCF of 4 comes down. Now everything is factored, and so I'm going to set each factor equal to 0. Now this first factor, 4, will never be 0, so that is not even one to look at. This next one we'd get x equals negative 5. This one would be x equals negative 2. And this one would be x equals 2. So we would have 3 solutions here. Okay. So when we're solving a polynomial equation, what we're going to do is first put it into standard form. Okay, that's where we have our highest exponent written all the way down to the lowest exponent. Then we're going to factor. So we have a variety of techniques for that. You're going to set each factor equal to 0. You're going to solve for the variables. So you're just going to, that's just where we set each factor equal to 0 and solve. And the number of solutions should be the same as the highest degree. Okay? So let's start with this first one. I got to make one side equal to 0, so what I'm going to do is subtract 33x from both sides. And then I'm going to look for a GCF. So we always start by looking for GCFs. All 3 of these terms can be divided by 3 and x. So what I do is I write 3x as one of my factors. I don't know why I'm writing this so far down. 3x cubed divided by 3x is just x squared. Negative 30x squared divided by 3x is negative 10x. Negative 33x divided by 3x is negative 11. Okay? So we've done the first step, and now we're going to look at this piece and see if we can factor. It's a trinomial, so you should be thinking ACB tree. So my A times my C is negative 11. We need the two numbers to add to negative 10. So that would be negative 11 and positive 1. So what I'm going to do is write this as x squared minus 11x plus 1x minus 11. Doesn't matter the order that you put the negative 11 in the negative or in the positive 1. Factor by grouping since we have 4 terms. So the first group has an x in common. Second group has just a 1 in common. Since our x minus 11s are the same, that'll be one of our factors. And the other factor is made up of the x plus 1. Bring down our initial GCF. And now we have this in completely factored form. Once it's in factored form, we just set each factor equal to 0. On the first one, I divide by 3 and I get x equals 0. It's a weird 0, I know. Next one, x equals positive 11. And this one, x equals negative 1. And those are our solutions. Okay, and notice the degree was 3. We have 3 solutions. All right, next one. Again, we want to make sure that one side is equal to 0. So we're going to subtract 36x and subtract 9 from both sides. None of those have a like term to anything over here, so I'm just going to write it like this. And looking at all 4 terms, I do not see anything that all 4 numbers have in common, so we're going to go right on into grouping. And in the first group, I could see I could divide those by 4x squared. And that leaves me with 4x plus 1. I have a minus sign here. I always make sure I bring it down. And I could divide 36 and 9 by, since I brought that negative down, I'm going to divide by negative 9. And that's going to give me 4x, whoops, I put the 9, 4x plus 1. Okay? Now, looking at what we have, I see the 4x plus 1s are in common. And I see that I have 4x squared minus 9 left over. So that becomes my other factor. Well, you better be looking at the 4x squared minus 9 thinking, oh, I could take the square root of those, and there's a minus sign between them. So you get 2x plus 3, 2x minus 3. And then we have 4x plus 1 here. Now everything is fully factored. So over here to the right, I'm just going to set each of these factors equal to 0. Okay, so my first one is x equals negative 1/4. I know you know how to solve these equations, so I'm doing these kind of quickly. Some of you may know patterns for these and don't even have to do what I'm doing. All right, so those are our 3 solutions. Okay, so I want you to try this one on your own. Try it on some notebook paper, and I'm going to pause the video so you could do that. When I come back, then check your answer. Okay, if you did this correctly, you would have gotten x equals negative 3 and x equals 9/7. I did the thought process that I had over here to the right, and we had a pretty intense AC value. So what I did was I made a list of factors, knowing that one of the numbers had to be negative to get a negative product, and I just started testing them out. Negative 1 times 189 didn't work. Negative 3 times 63 didn't work, or should I say plus. Negative 7 plus 27 didn't work, but negative 9 plus 21 did. Okay, let's look at this example. Well, on this one, I want to move that 1 to the other side, so I subtract 1, and this is a difference of squares. So solving these out, remember we're just setting each of these equal to 0. So, yada, 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 we would get x equals negative 1/9 and x equals 1/9. This next one, I could factor out an x from each term. So I'll get x to the 4th minus 10x squared plus 9. And when we look at this one, you may remember when we did this in school, we saw that any time that we had an exponent at the beginning that was double the exponent in the middle, we could use an ACB tree. So my AC is 1 times 9. And we need the numbers to add to negative 10. Well, in order to have a positive product and a negative sum, we have to have double negatives. So that would be negative 9 and negative 1. So what I'm going to do, so I have that x. I'm going to rewrite this now as, or sorry, I don't want to do this over here. Let's do this over here. So I want to take this part and write that as x to the 4th minus 9x squared, because remember we have x squared in the middle, minus 1x squared plus 9. Okay, we're going to factor that by grouping. In the first group, I could divide those by x squared. And I would have x squared minus 9 left over. Minus sign in between. I could divide these just by 1. And I'd have x squared. Oh, that's really a negative 1, sorry, because we had a minus sign that we factored out. So x squared minus 9, which means that my factors for this are x squared minus 9. And once I use that one, I have x squared minus 1 left over. All right, so looking at what we have here, we need to break both of these down. Their differences of squares. And then don't forget your original GCF. And now we're going to set this equal to 0. So x equals 0, x equals negative 3, x equals 3, x equals negative 1, and x equals 1. So we have 5 solutions, but we have a degree of 5, so that makes sense. Okay, I'm going to have you try this one. Start by looking at your GCF. Go ahead and try this out, and then we'll check our work. Hopefully you got this far. I want to just take a moment. You probably know, you probably know that these are going to be t equals negative 1/2 and t equals positive 1/2. Those you probably have. And you might be thinking, okay, how do I do this one? Well, let's do that out to the side here. So t to, so sorry. All right, so you might be saying, okay, t to the 4th equals 0. Well, how do I get that 4th root gone, or that 4 gone? Well, just remember this is saying that if I have t times t times t times t to equal 0, that means this t is 0, or this t is 0, or this t is 0, or this t is 0. So you only need to write t equals 0 one time, but just remember this has what we call a multiplicity. So the number of times that 0 occurs, it occurs 1, 2, 3, 4 times. Okay, and so when you're looking at that solution, you might be thinking, wait a minute, Mr. Bayer, you said that the degree had to match the number of solutions. Well, we have 1, 2 here. This one has the additional 4, so the multiplicity of 4 is telling us that that 0 happens 4 times. So there's my 4 solutions here, plus these 2 additional solutions. That gives us 6 total solutions. Okay? All right, so now you're going to try some IP problems.